And today we are going to take up AI for data analysis, probably, which is the most important aspect of use of AI in a way. So it's not going to be complete AI. We are going to use a tool called Orange, which is, I think, quite remarkable. But then this is where we introduce Dr. Atul Tiwari. Now, Dr. Atul Tiwari is by profession, just like a lot of us, he is a Batman, right? So in the daytime, he's Bruce Wayne. He's assistant professor in pathology at GMC Chittorgarh. And at nighttime, again, like a lot of us, he moonlights as a AI person, as a tech entrepreneur. So he's a consultant with MedPrime Technologies. He's a research wing leader at Doctors AI, which is a collaborative tool system for doctors who want to be part of AI. He is MD in pathology. He has a lot of degrees in the AI field as well. He has published several original research work in AI in healthcare. He has developed medical mobile 3D educational games, which are available on Google Play Store. He's proficient in a lot of no coding tools, but actually, what he doesn't tell you is actually very proficient in coding as well. So he's an expert in Python. And this is where we got first in touch with him. And when we were going through, we had one workshop long time back. At that point of time, somebody told us about Dr. Atul, and we looked at some of his videos and we said, we need to have him for our AI sessions, where this guy is fantastic. Dr. Atul Tiwari, welcome. And thank you for accepting this on behalf of the endocrine community. And thanks for teaching us something very valuable, which you're going to teach us today about Orange data mining tools. Before we begin, let me just give you a brief introduction of what is Orange. So Orange, the idea of today's lecture, it's going to be a little different because today Atul is not going to put a presentation in front of us, right? He's going to actually show the live demonstration of the whole thing. And that's the whole idea of this entire program. So he's going to show you, Orange is actually a research tool. It's a no coding research tool. So you can actually, and you'll see how you can upload the data there and you'll get some interpretation of the data also. It uses machine learning and a lot of other algorithms at the back end. So you'll be seeing how. And what Dr. Atul is going to do something very unique. He's going to actually take the help of ChatGPT also to understand Orange better, right? So we'll do a sort of a collaborative kind of thing with Orange. So Atul, welcome. And the stage is all yours. Originally, there should be a short lecture on using AI for data analysis, but we'll not waste any time because we're very excited about learning about Orange. So we'll go straight to your talk. And Atul, please take the stage and welcome once again.
Thank you so much, Dr. Om. I believe you have exaggerated the kind of things that I do. And now you have set the bar so high, like by the end of this lecture, if any of the audience can say that whatever has been told about me, like fits into the picture. And if the audience, every single one of them is able to understand whatever I'm going to teach today, then only my lecture would be justified.
Absolutely.
So without wasting any more time, I will start sharing my screen first, and then I will start explaining in a very simple way, like what I am doing, what the things are. There is a reason I will be following a set pattern today. I will explain you whenever necessary. Those who are very new, Dr. Om, can you confirm if my entire screen is visible to you? You are on mute.
Yeah. We can see your screen, Atul. Yes.
Okay. So before starting anything, like those who wants to replicate things with me, like Dr. Om mentioned, Orange is a data mining software. It is a very good software where coding is not required and you can still make very good models. I will like put a stress on it, like it won't be a market ready model, but in the research world, it is equally acceptable. There are a lot of papers have been published using Orange. I will show you how you can create your own model. And I will explain you quite a few things. I will skip a few things. I might even tell you like I'm skipping this because it is not a software that I can teach or anyone can teach you with or anyone within 1 hour or 2 hours or even 5 hours. Like when I take an entire course, it takes more than 90 days, a 1 hour session of each day to explain each and everything, why I'm doing certain things and what are the other approaches. But for now, to give you a like crash course on Orange, those who wants to replicate with me, they can go to this website, simply search. Those who are on Windows, just search download Orange data mining. There is a first link, download Orange. In this, for now, I want you to download the portable version because in standalone installer, the Python setup required, depending on the configuration of your machine. So that's why I would suggest to download the portable version, because in that everything should be in place. And this is in my virtual machine. I'm just demonstrating it. I'm just seeing if everything is in place here, because right now it is in my virtual machine. I will switch back to my Mac OS. And in case of Mac OS, it is very easy. Here you just again Orange data mining tool, download. And here for Mac OS, you just need to click on download, and then I will share. Dr. Om, can you share that link of the Google Drive in the?
Okay, I'll share the link for the Google Drive. So that is all the resources. So we have put the link for the same, and I think we'll share the other link also, which you sent me.
Because if I need to show the entire installation process, then it will take some time. Behind the scene, when I'm explaining, you can just go through these steps and let it install. So this would be the screen in macOS. Once you download the macOS version, depending on if you are using M1, M2, M3, M4 Apple Silicon laptop or macOS, then download the Apple Silicon version. Otherwise, the Intel, if the machine is older one. Mine was Silicon one, so I downloaded that one. And once you just drag and drop, the installer is very easy. If anyone has installed anything in their macOS, simply drag and drop it to the applications folder shortcut given here. And when you first run, you just need to click on open. Basically, this is a security setting by macOS. You just need to click open. So this is a very small introduction on how to install macOS. If someone is facing any difficulty, I will troubleshoot in the end, because right now, if I start troubleshooting each one of you, then the entire session will be on the troubleshooting itself. So those who are able to download it successfully or are downloading, let it download. Meanwhile, once you have downloaded, what the first screen would look like, let me open a new Orange notebook. So this is a blank file. You might see a pop-up when you first open it. So new, open, all those sort of things. That is for the faster workflow. You can click on new and come to this screen. So here, this is
Atul, can you give me I'll just reiterate, dear audience. So basically you'll have to download. So Orange is a software which you'll have to download. What you'll have to do is we have put the link for the download there. Now you might be having either a Windows laptop or a PC or a Mac OS. And if you are using Windows, try to download the portable version, because the reason is that some of these tools require Python at backend. So if you download the portable version, it will have Python pre-installed, so you don't have to do anything extra. Whereas if you are using the standalone, the standard process, then you will have to install some more stuff, which will take more time. Secondly, if you're using Mac OS, already Atul showed you the process of downloading using Mac OS. If you're using the older Mac, which is basically Intel, then you'll have to use that version. Or if you're using the newer ones, you have to take with the M1 chip or M2 chip or M3 chip, then you have to download the one which is for Apple Silicon. So just download that. It will take a little time. It's a little big file, as I understand. It'll take time. So don't worry, just take your time, download it. The idea is to broadly see the principles which Atul is going to show you. And then if once you download it in your laptop or in your PC, then you can come back and view this lecture again. We'll have the videos as well. So you can view this lecture again, and you can then reiterate the steps which Atul is going to show you. Atul, yes, please go ahead.
Yeah. So yeah, that's a brief summary that Dr. Om gave. It's very good summary. And in the end, I also would like to add that don't worry. Even if you fail to install it, then just don't worry. Don't try to troubleshoot on your own. Try to focus on the lecture itself. Later on, in the end, if someone faces difficulty, I will be here. I will try to resolve it. And even if it is not, then we will try to troubleshoot it in a later WhatsApp discussion, or we will troubleshoot it, because there is no way it cannot install. I have installed it in so many laptops, and so many workshops have been done. I have not seen any single mistake. But then again, in the entire presentation, I will go through at least 2 projects and 1 basic demonstration. So there is ample amount of time for you to replicate with me. If you are not able to match up the speed with me, I would suggest don't replicate with me for the first trial things when I'm going to show you. Like right now, it is 8:45. I will tell you when the first session of introduction will be over. Then I will start with the first actual project. At that time, you can start replicating with me. For now, just focus on the things which I'm going to show. So with that information, let us start. So this is the basic UI of the Orange. On the left-hand side, we will see so many widgets are there, like file, CSV file import, datasets, like 9 widgets we can see in this data header. Then there is transform. In this, there are so many widgets are there. These are called widgets. In some of the other no-code apps, it is called nodes. And there might be many names. Our aim is to use this software and create a model that is applicable to our research work. So anyhow, we will try to learn as many nodes or as many widgets that are possible. In case of transform, first, in case of data, today I will demonstrate only file widget, and later on, when and wherever needed, I will also show you data table. Right now, I'm not going into detail. I'm just telling you briefly which widgets I will show you. In case of transform, I will use data sampler. So you know where it is placed. So when I say data sampler, you can either use it from the left-hand side, from this transform header. Just click on it, it will expand, and another click, it will minimize. Similarly, in the third one is the visualize, all the widgets which are used to visualize the data. There is tree viewer, there is box plot, there is Gaussian plot. From this, there is scatter plot, line plot, bar plot. Can you recall those who have done thesis? I think almost all of us have done thesis. All of these things are like in the statistical diagram we use to make this. The same diagrams will be used in Orange or in our research work in the field of AI also. So all of these things have Python programming in the backend. So that's why we don't need to code right now, and everything is in place. I will show you how to connect the dots. Then the third thing or the fourth thing comes is the model. This is the brain of our like today's talk and also in this AI journey. Our ultimate aim is to make a model, functional model or a research grade level model with an accuracy of, let's say, like 70 to 90%, depending on how good our data set will be. So in case of model, you might see some new terms which some of you might not have heard, but for the sake of simplicity, I will not go into mathematics. Like for example, random forest, if you simply Google it, random forest algorithm, it is one of the most common algorithm that is used in machine learning. It has complex formula, literally very complex mathematical formula. Those who are interested can go for learning in about it. And today, like when Dr. Om approached me, I also told him that for doctors, I don't want them to be like afraid of AI. That's why today I don't want to go into the mathematics. Those who know like this summation, function, and limit, all those sort of things are there. But for us, for simplicity, I will enumerate some names and I will also focus my mouse on those names. You just need to know that in the world of AI, there is a subset called machine learning. There is a subset called deep learning. There is a subset called NLP, natural language processing. All those sort of things are there. So machine learning is one of the subset of artificial intelligence. Deep learning is another subset of machine learning. So today we are focusing on this machine learning part. In case of machine learning, there are so many algorithms that scientists or computer scientists have developed, and they have evolved with time. Random forest, if you go into history, I think it was introduced somewhere around 2001, if I'm not wrong. Like, so this is one of the ML algorithm or machine learning algorithm that produces a very good result. There is another model, there is another ML algorithm that is called as gradient boosting that we will use. There is one more that is SVM, support vector machine. There is linear regression, there is logistic regression, naive Bayes, ADA boost. All these, or one more is there, KNN. These we will use in today's project making. At the time of making, I will also go into little bit deeper. Right now, I'm not going like bombarding you with so many overwhelming things. But I'm just introducing you with some new terms. If someone knows about them, then it is very good. If someone doesn't know, don't be afraid. All you need to know is in your research work, you need to use random forest algorithm, you need to use logistic regression, you need to use AdaBoost, and whatever model algorithm that you have used, you need to write it in your research work and whatever output that model has generated. Right now, I might not make sense to some of you. Just please bear with me for another 15-20 minutes. Everything will start making some sense. So once we have created a model, then the next step would be to evaluate it. So for the evaluation, there is something called as test and score, then predictions. Then there are one more thing that I will use is confusion matrix. So these three I will use. Lastly, this unsupervised. Today, we will not touch it. I will tell you why. In the end, once you have gained some confidence in building some model, at least one model, when you have learned how to make it yourself, then you touch upon unsupervised learning. I will briefly tell you about unsupervised learning, not like showing you any project on that right now. So with this information, let me first show you, at least in AI world, you need a data. For any thesis or any research work, you need a problem statement first. What do you want to do? For example, for today's discussion, I have planned to show you two projects. One is diabetes prediction. So as an endocrinologist, I'm hoping like most of you are working in endocrinology domain only, although some of you might be from other sources, those who have connected here. But still, I would like to tell everyone, whatever now I am going to show you, you can apply it for any problem statement, not just endocrinology, not just diabetes prediction. So I will go to Google Scholar. Like right now, I'm doing all the steps as a newbie. Like I don't know anything, but I know how to connect things with ChatGPT and how to connect it with forums. What I will do is I will simply search, like right now in my mind is like I want to work on diabetes prediction. So now I know diabetes prediction is through using machine learning. Right now, I'm not using deep learning. Can anyone tell me in the chat? I will later on read it. Like why I didn't read. Sorry. I will put it on a flight mode. Oh, sorry. Okay. Diabetes prediction using deep learning. Sorry, machine learning I'm using. I'm not using deep learning. I'm not using NLP because in case of diabetes, when you plan a research work, what are the different variables that you can use in case of diabetes prediction? If you are like working on as a first year MD medicine or a first year DM endocrine, and you want to make some study on diabetes, what parameters will you choose for your diabetes study? Right now, we are not discussing about prediction. Can anyone just briefly write in chat quickly? What are the different things that you need to understand, like whether the patient can have diabetes or not? You people are like the better person than me.
Okay, so grossly speaking, Atul, we are looking at the age of the person, the BMI of the person, the weight of the person, maybe the abdominal circumference and so on, waist circumference and so on. So that could be the tools which we have for prediction, right? So we are,
Yes.
yeah.
Yeah. So basically, we need to have our certain like data variables which are specific to our problem statement. So when I went on to Google Scholar earlier today, I found out two like one easy and one intermediate level research work that I wanted to show you today, like how to do these kind of study. So every study has some methodology, and in methodology, you need to see like what data is being collected. So what Dr. Om said, in case of diabetes, there is something called as PIMA, if I'm correct, in diabetes, PIMA guidelines. Is it?
So PIMA it's an ethnic group who have very high predisposition for PIMA. Indians are an ethnic group which have very high predisposition for developing diabetes. So that's why all this data, a lot of it comes from there because they develop diabetes much earlier and very common in them. Yeah.
Yeah,
So
please
what
continue.
what Dr. Atul is showing is something called Kaggle. So Kaggle is a free online resource for data. So it's some people have put their data sets and they want others to develop models based on that. You could also, if you have data which you own or which you have, actually share it on Kaggle. It's like a open source for data sharing, right? So that's Kaggle. So you can, if you want to try out a lot of these things, you can actually go to Kaggle. If you don't have your own data, you can, to learn all this, you can go to Kaggle and download some of these data sets. They are freely available and you can try it out yourself. Yes, Atul.
Yeah. So as Dr. Om has mentioned, I have shared a Google Drive link with you people where this first study is about diabetes prediction using machine learning. So here they had mentioned about these particular data set that they used. And I similarly, I went ahead on the Kaggle website. And since I don't own any diabetes data set of my own, and since this is an endocrinology workshop, I specifically wanted to show you something related to endocrinology. I searched about the diabetes dataset. And once you are logged in, right now I'm logged in, then only you can download a dataset. But for the sake of simplicity, if you don't know like how to create an account, although it is a very like simple click and go, like login with your Google account, you can easily create your account. But if you face difficulty or if you are short on time, I have already downloaded this particular data set in the zip format, and unzipped one is this diabetes.csv file. It is the same file that is present on this Kaggle website. I have not modified it. And every modification, if I do, I will show you in the live workshop only. So this is how we download the data set. So I have it in my MacBook. And so also I want to say, if you see, the file has an extension of .csv. If someone is new, it is like an Excel sheet, but in a simplified way. CSV is comma separated value. If I put a number, like if I put my name, Atul, comma male, comma 37, that is age, this, if I put, instead of putting it in a sheet, in a column, then it is called as comma separated values. But CSV files can be very well read in Excel. But if you are working on a CSV file and later on you plan to use that same CSV in any of the machine learning, like either in coding or in Orange or in any other no-code tool like 9, and many more are there, then I would like strictly suggest you not to click on save. If you make some changes in the CSV in Excel, then try to maintain the CSV structure. Because what happens is, if I want to create a chart in this particular file, then the CSV file structure will be broken, because then it will be converted into an Excel file. Because Excel has the ability to sort things, filter, sort, create charts, all those sort of things. Today, for the sake of simplicity, I'm just showing it you in a Excel. There are many easy softwares also, like Visual Studio Code, which I use frequently. But since you don't know coding, I won't show you. So in Excel, if I see this particular data set, so here I can see like it has one column named pregnancy, another column named glucose, third one is blood pressure, fourth is skin thickness, fifth is insulin level. Sorry, insulin, it like we will have to go through the data set also. Like what
it's insulin level. So they're probably doing fasting insulin level for prediction. So
yeah. And then comes the BMI. Here is diabetes pedigree function. I'm sorry for some certain endocrinology terminology. I won't know into that much detail, for which you are more like knowledgeable than me. But you can correlate what these parameters are. The second last is, and finally, whether the patient has diabetes or not. It is in binary format. If diabetes positive, then if he has diabetes, then outcome would be 1. And if the patient does not have diabetes, then it would be 0. So the same thing, when you create your own data set, you should have the definitions for it, so that if it becomes easier to understand. So here I can see insulin is to express the insulin level in the blood, and lastly outcome to express the final result. 1 is yes and 0 is no. So this is how my data set looks like right now. But if I use this data set in Orange, let's say, how should I use it? So the first thing in any software, if I want to open a file, I need to open it with a particular trick. Like generally, in case of Word, we open it in go in file and open or press Control O. Here, if I want to open a data set, the best or easiest trick is click on this file widget, drag and drop it. Here it will be there. Now double click on the file. It will ask you the location of the data set. If you are opening for the first time, then by default an iris.tab is also another format of using machine learning dataset. Here, instead of comma, tab key is pressed. But ignore that for now. I'm focusing on my diabetes dataset. So I will click on this three dots. I will locate my dataset. Right now, I think it is in my downloads folder. SAIL-ESI. Yeah, here it is. So I will locate my file. I will click on it and I will click on open. Don't close this tab because we have certain things to do with it. So once I select my data set, what will I see? There are 768 instances. What does it mean? There are 768 rows. Can I tally it in my Excel? So you can see 769. The first row is header. So there are 768 instances. There are 9 features. So what does this mean? There are 9 variables are there. These variables are there. Out of which, if there is any missing value, right now in this particular data set, there is no missing value. But in real world, there will be missing values. For example, if you have given a task, making this data set from the OPD patient or from IPD, obviously you don't do it. You ask many interns to collect the data for 6 months, and sometimes some patients might not be able to give you correct information. Sometimes intern will forget to collect that particular value. There will be missing values, and we need to make a note of missing value, because later on I will show you what are the different possibilities or different futures that can be decided based on the missing value. How can we deal with those missing values? So in this first example, here it is an easy one. There is no missing value. Data has no target variable. So what does this mean? That our Orange software was not able to decide which particular column amongst these is the label value. What is our problem statement? Our problem statement is, I want to predict diabetes. So what do I want to predict? Diabetes. So which is that column that I want to predict? That is my outcome or label column. In Orange, I need to assign it as a target. So my outcome value, if it is set to feature, it is wrong. Something we need to predict. In case of PCOS, I want to predict PCOS. So the outcome, whether the patient has PCOS or whether the patient does not have PCOS, it would be my target value. So I need to change the role to target. Otherwise, I will face error later on. And believe me, I have seen beginners making this mistake. They fastly select the data set and just click on apply and close everything, and later on scratch their head for half an hour, more than half an hour. What went wrong? Because this is the common mistake that I have seen. Apart from that, what are the different values that we see? Now you can correlate all these value: pregnancy, glucose, blood pressure. All these things are the same that we see in the Excel sheet as column. So these are the different features that we are seeing. Luckily, not luckily like 100%, but yeah, here the data set is very well structured. So everything we see is in numeric format. In case of machine learning, the Orange software, it fits. Where does it fit? As per our endocrinology work, it fits wherever the tabular data is given. But not only just it should be tabular, but also it should be numeric to create a machine learning model. If there is, in case of pregnancy, if instead of this 6, if I remove this and if I write 6 like this, then it would create problem. It won't make sense for machine learning. So ultimately, for the entire table, we need to convert in a number. First thing. Second thing, the numbers should be in a particular order. What do I mean by that particular order? I will come to it briefly when I will jump to next visit. First, let me explain this particular visit. So pregnancy is a numeric type. Yes, it should be numeric only. What do we mean by categorical? For example, here in this particular data set, the gender is not there. But let's say let me reset it to numeric only. Let's say if someone has decided, okay, gender also plays a role in diabetes prediction, so I want to collect in my data set the gender also. So what will be the gender? It can be categorical also. It can be numeric, but I won't. You might say, if I say code 0 for male and 1 for female, then it should be numeric. No, those kind of things will happen, but then we will define it later on. In the beginning, those values like male, female, if age is not there, and if I am coding it as adult, child, pregnant female, elderly people, then it would be categorical only. So we need to have a clear picture in our mind, like what should be the type of our variable that we are working on. Next thing is role. Everything is a feature in this except outcome. What are the other things? Target, I already told you. What is our outcome? What do we want to predict? That only that particular column would be our target. Meta means any additional information. For example, let's say I'm working in a hospital setup. I told my intern to get all the data for me. But if I want to trace that particular data, with which patient does this data belong to, I might also use hospital number, the patient OPD or IPD number, whatever number you have assigned it to him. Then what was the name of the patient? In my study, when creating a model, those values are not important, but to trace it back to the patient, it might be necessary. So if in my data set it is there, can I use hospital number or can I use the patient name to predict a model? It is logical. If a patient having a name as Shyam does not mean that he will be having diabetes. So that's how we can skip it, or we can select that it is a meta information. Don't use this information while making a model. So that's all 4 different types of roles are there. Mostly we will select feature and target. And if there is nonsense data or not usable data, we will skip it. In the next demonstration, I will show you such data or such column which we will skip it. So right now I will set it back to feature. So quickly, can you let me know in the comments, and Dr. Om will see if you are able to follow me till here.
Yeah,
if not,
yes.
if not, then let me know.
Yes, Atul, we are able to follow. Just for the audience, so I'll tell you what Atul is trying to do. So we have downloaded the dataset, free dataset from Google. Of course, you will be using your own dataset, which will be available to you for your thesis or for your research paper, which you're doing. So what you'll be doing is right now. So the idea, for example, in this dataset is that we want to use certain variables to predict whether the patient is likely to have type 2 diabetes or not likely to have type 2 diabetes. Now, of course, we'll all argue till cows come home that these data are not generally what we use for prediction, but this is somebody's data set. So it's not our data set. So we don't have to worry about that. Secondly, so this is the available. So you could assume there could be waist circumference, or there could be some other BMI and other data. That is what ideally we'll use for prediction. But let's assume that this is the data which is there. Now, what Atul is going to do is he's going to make a model based on this pre-existing data where we already know the outcome, right? So this is a training data. So for example, we already know that some of them have diabetes and some of them don't have diabetes, right? So what are the variables which are impacting the patient likely to have diabetes? That is what we are predicting right now, right? So he'll basically take this data, he will upload it, he will make a model, and then we will get that model and then we'll test that model. So that is how we are going to do. Atul, am I right so far?
Yes, you are very right. And like Dr. Om mentioned, that in real world setup, we might use different set of like variables to predict the model. As I was also telling, like gender can be as one of the parameter if the patient is suffering from hypertension. So there might be different types of things we can include in our study. Right now, I am demonstrating on a sample data set which was available free of cost. Thanks to those people, they uploaded it for us to study. But you can use in your setup whatever suits you better, like whatever you think with your knowledge, like this should be the ideal data set, and you can start collecting it. For the beginners, I would suggest collect as much data as possible. Later on, go with the ablation thing. Like, for example, if you think age is not a suitable parameter, later on you can drop it. But in the beginning, collect as much data as possible, because once you start creating a model and then you realize, oh, you forgot to collect the gender. Let's say in this particular example, gender is not there. So then it would be a problem. So with that information, Let us go back to here. So I have set the values of target. So since it is a categorical value, in the value column, I will see 0 and 1. So now I will quickly click on apply and close this particular widget. If I need to go back to this particular setting again, I just need to double click on it. Okay. So this was one method through which I can use this file widget, drag and drop. There is another method also, which I use or which you will use more frequently because that is easier to use. In this white area, this is our workspace area. Anywhere where you want to load a widget, just right click on it and entire list of all the widgets available will open up. So if I need to open file widget, I just need to type the file or I just need to select the file widget from that drop down list. And the same thing can be done through here also. So once I have loaded the file widget, earlier I showed you on the Excel file, in the Excel, like how my dataset looks like. But in real world, I don't use Excel for my machine learning project. Now, you can see these dotted lines. These dotted line means something can be connected. Since this dotted line on the right hand side, something can be connected with this file widget on the right hand side. So when I click on this dotted line or hover my mouse on the dotted line, I simply click on it. I don't lift my finger up, let the cursor or the screen or this change dotted into a solid line with a dot on it, and I will drag my finger. Simple. A connecting node will open and it will ask me like what next widget I want to open. So here, the first thing what I want to do is I want to visualize my data. So for visualization, I will use data table. Where I had shown you data table, left hand side, this second row first widget, data table is there. So that's how we load the next widget and connect it. So once I double click on it, I can see my entire data set here. Since I had set outcome as my target value, you will see it in a different color. Apart from this, all the remaining you will see this is white and grayish separation is there. On the left hand side, now you can see there are 768 instances. It means there are 768 rows. Now instead of 9, there are 8 features. Why? One feature we have converted into target value, that is outcome. Then our target has 2 value. Either the patient has diabetes 1 or he doesn't have diabetes 0. There might be cases when these values might be more than 2. But for the sake of simplicity, today we are going to work on 2 values only. So that's how our dataset looks like. But now I am intentionally making some mistake to let you understand what happens if I make that particular mistake. Before that, let me just click on this data table and drag and drop here to show you. Like in case of file, you see something can be connected on the right hand side. But in case of data table, you can see the dotted lines on the both sides. Like on the left hand side, if I click and I can drag. So something can be connected on the left hand side and dotted line on the right hand side. It means something can be connected on the right hand side also. This GUI framework of Orange, this is one of the best things that I like about it. If someone doesn't know programming, it becomes very easy. You just need to understand the steps. First, I need to load the data. I need to visualize it. Then something called as EDA or exploratory data analysis comes into picture. Like how does my data look like? The first part of EDA was this data table. This is how my data set looks like. I can visualize it in another way also. Like on the right hand side, if I click on data table and if I click on anything in particular, if I want to visualize it like in distribution, let's say, there are so many things. Later on, you can go with this and try to explore it in as many ways possible. Whatever I did, I will explain you. Let's just see. So I selected a distribution widget. It is there in the left hand side. You can see in visualize tab, it might be there. So what does distribution mean in your research work? For my study, how many male patients were there or how many females were there? So those sort of things. For pregnancy, for example, if there are 2 values, either pregnancy was there or not there, so 0 or 1, those sort of things we can see in distribution. So blood pressure values are there. So these are categorized for like 0 or 1 means here this outcome. Can you see this one? 0 is what is 0? If you can recall in our particular data set, where was this one, Pima? Here. 0 was for not having diabetes.
Not having diabetes, and 1 was
So,
1 with yeah.
One was having diabetes. Okay, so the same thing. So here our 0 is not having diabetes, 1 is having diabetes. So why did I visualize it? The first thing that I need to keep in mind in medical science, that one of the biggest problem using AI, or one of the biggest drawback in healthcare sector, is we will have normal values far much more than abnormal one. That's one of the reasons AI model failed in real life. So here also, although this is like a very basic data set, we can see somewhere around 500 numbers are there for this person not having diabetes, but somewhere around 270 maybe those number of people have diabetes. So this is called as class imbalancing. In your case also, you might see these sort of things. In real project, you need to tackle this class imbalancing. I will just throw a term to you because today I can't go into details of machine learning. So this is called as SMOTE. You can go later on, try to figure out what is SMOTE. It is synthetic minority oversampling technique. What does it mean? Those sample which have lower number of values, for example, here diabetes, patients having diabetes are quite less than patient who doesn't have diabetes. We need to create synthetic data using our real data to solve this class imbalancing. This is one of the way through which I can tackle this. Another way, here our data set is very small, but let's say if I have a data of more than 10,000 people, and out of which 7,000 have diabetes, don't have diabetes, and 3,000 have diabetes. It is again an example of class imbalance. But in that case, what I can do is I will take all 3,000 patients who have diabetes, but instead of taking all patients who don't have diabetes, I will hardly take 3,000 to 4,000 patient data who don't have diabetes. So this is another way. I will drop out certain rows, but then in my methodology, I will mention like why I dropped these values and what was the criteria, which row I will delete. Generally, I will delete randomly, but if there is any specific reason, like I will delete patient data of less than 18 because I didn't have the consent, then I will have to mention that also. So now I know sky blue is patient who don't have diabetes and one is patient who have diabetes. So similarly, I can visualize the rest of the data, like how does it look like? And these things, depending on which particular variable is very significant, I will show you in the end. We can take a screenshot and put it in our research work also. So this is how data table and one part of EDA works. And now if you remember, I clicked on this data like thing and another setting opened. Earlier, what was there? It was connected like this, selected data with the data. By default, this is the setting. This is one of the reason also, if sometimes some user forget to change these settings, they might not see anything in distribution or they might see wrong things in distribution. So what does this mean? If I want to visualize only these selected rows, then only those values will be there. Can you see the number of values have been decreased to 5 only? So it depends on how we try to visualize data. So I just double click on it and every node, which whenever the connecting node are there, something similar to this screen will pop up. You can change it. At times, sometimes values will be locked, which means those are not the correct settings. I will show you later on where those comes. I can just simply hover my mouse on the center screen. I can click on cross, and now I can set my entire data and just click on it and drag it and connect it with the data of distribution. That's how, and click on OK. That's how I change my setting. So now if I click on distribution, I can see that in my outcome, all the values are there. So that's one of the basic settings. Now I will connect my data table to another tool that is called as pre-processing. Pre-processing is required. It is like a rule of thumb. One type of pre-processing or another type of pre-processing will be done in your study. How it will be done, I will show you later on. Right now, I will just show you some settings, and I won't do pre-processing to intentionally show you how things can go wrong. Also, can you see again what happened? Selected data and data. That's how the things are connecting. I don't want it. I want entire data set to be connected. So I will just double click on it and I will change my setting from data to data. Now, if I want to see the settings of pre-process, I will just double click on it and an entire set of statistical tools will open. Those who are like very good in statistics can correlate, but for basic things, I can show you some things which are very relevant to you from easy to hard, like normalize feature. In case of normalize, let me just show you one thing. Yeah, here it is. Do you see here age is 50 and the second one is 31. There might be some 20, there might be some 17. What is my lowest value in the data set and what is my highest value in the data set? Like person A is collecting some data, person B is collecting some other data in other hospital. These can be different. Please try to understand this. The lowest age can be different as per your study protocol. The highest age patient can be different. Like you might set that patient above 18, I will collect the data because it is easier to get consent, and there will be no upper limit because diabetes can have occur at even 60, it can occur in 70, it can be there in 90-year-old patient. But let's say researcher A who is working, let's say Dr. Om is working, and he doesn't get a patient of 90-year-old who is having diabetes in his study duration. But some researcher is again like I am there and I am getting more patient of 90-year-old. And if we both try to make a model, the model will have some problem because when I'm training my data, I'm showing the model, or the model is picking up the values like a 90-year-old patient have diabetes. But in case of Dr. Om's data set, what will happen? Let's say highest is he got during his study period was of 75. So machine will understand that above 75, diabetes does not occur. So these are some common pitfalls of doing these kind of things in a resource limited setup, or like certain constraints would be there. So to tackle these, what we do is we pre-process our data, we try to normalize the interval, and generally, I'm saying generally, you will see normalized to interval 0 to 1 would be there. Again, I told you in the beginning, and teaching entire orange is more than 90 years of thing. Sorry, 90 days of things. So I'm just quickly going through the main tool that you will use here in this study and even next study and even most of the study, you will use normalized to interval. Second most thing, you can use standardized to 0 and 1. But depending on the type of study or type of problem statement, you will use it. You can also try ChatGPT. And here, just before talking to, like starting this chat, when I was waiting for you people, I simply throw out the data and I just ask, I want to make a diabetes prediction model from this data set using Orange data mining software, write a detailed approach. It gave me an approach. It told me like, these are your values. All columns are in numerical, so I don't need to change it. Overall steps, what would be my steps? It enumerated everything. So you can also use these kind of LLM also to help you, to better help you with these projects. So in the first step, I have already told you how to load the data. It mentioned drag and drop the file widget, load this diabetes.csv file, make sure the outcome is set to target, that I already told you. Then comes the data cleaning. Today, I didn't go into data cleaning part because right now, it doesn't require data cleaning. Maybe in the next project, I will show you how does data cleaning work. Then comes the EDA part. I showed you the distribution. Like ChatGPT is showing me, if I want to go for a research work, then box plot I can make, scatter plot I can make, sieve diagram I can make. Okay. Just quickly, I will just demonstrate. box plot also. So just I need to click on it and I can just see how does my box plot look like. Those who understand how does box plot work, they can easily correlate with it. Those who don't, anyways, when you are doing these kind of studies, you need to understand like already published study, what different parameters they are using. So this is the box plot visualization. All those sort of things can occur. So you can take help of ChatGPT. What different types of EDA I can use? Simple, you can go into detail. You can ask what are the different types of EDA that I can use in this particular setting. Then next step is applying PCA. PCA is another important thing that I want you to explore on yourself or attend some other or advanced Orange workshop when you are far much more interested in working with AI work, because it later on it would help you create better model. Today I can't go into PCA setting. Then comes our AI model making step. So here, can you see it forgot to mention the pre-process step. So this is the thing. That's why we can't entirely rely on ChatGPT. You can see here it forgot to tell us about pre-process. And later on, I will show you, like right now, if I don't pre-process anything, I can remove it here. If I remove, I don't do anything, and I will straightforward go to next step. What will happen? I will show you. But before that, I showed you normalize feature is there. Then there is impute missing value. For example, if your intern forgot to collect some values, and now what do you want to deal with those rows? Let's say patient A is there and we forgot to collect the BMI value. I have three options. I can use the average value that has occurred most commonly in my data set, or I can replace it with some normal random value. Lastly, I can remove the missing value. Personally, I prefer remove row with missing value because I don't want to corrupt my data with some random value or taking out an average value. Taking out an average value helps when the data set is quite large. 1 million rows are there and hardly 5,000 to 6,000 data column cells are missing. Then I can take the average. But otherwise, I will try to remove the row and I will proceed to next step. So I showed you normalize feature is one of the important things that you will anyhow use. Another will you will use is impute. Third one, I won't go into detail. This PCA setting, here you can set the number of components that you want to work upon. But what is PCA? You need to Google. So let's say I have given you two homework. One is SMOTE. What is SMOTE? How can you use it? And another one is PCA. So these two things so far I have told you to explore on yourself because these two will be important. So I'm not setting anything in the pre-process tool. So now I'm just simply connecting it to the next thing that is called as select column. Some of you might think, how do we decide which thing to pick up, which widget to pick up one after another? So this is the basic workflow of a machine learning model that we first take up our data set, then we visualize it. Then if needed, we need to clean it. And if needed, we need to normalize the data set. If needed, we need to drop some rows. After that, whatever column we want to study upon, we select those columns and then select the machine learning algorithm to create a model. This is a common approach to entire AI prediction model. So there is no need to mug it up. With practice, it would be in your reflexive, like what next tool I can use. So here you can see it is correctly connected my pre-processed data with the data. Since I didn't pre-process anything, I can simply click on my data table and I can connect it with the select columns. Instead of selected data, I will just select data. In the selected column, since I have opened this particular data set so many times that Orange remember, my target value is outcome. But in your case, what might happen is, and all the values or the column names will be in features or will be in ignored. It can be like, depending on your type of study, it can be like this. So basically, select column widget. What does it do? I need to select what are my features and what is my target. So for me, all of these are my features. Then this outcome column, it is my target. And I don't need this selected one. because I demonstrated you some rows I selected. That's why it is showing me selected here. In your case, it might not even show. So I need to set these things like this. Okay, just give me a second. Sorry, I am having one important message. Okay. Meanwhile, just can you fill it up if you are there? Like just
Sure. If you could stop sharing and just whenever you're ready, you can come back. Okay, friends, I'll just show you another example so we can again start from there. So let me just share my screen meanwhile. Okay. So meanwhile, till we get, so for example, we'll go step by step. So we'll go to Kaggle, Kaggle. So this is Kaggle, right? Here I've downloaded a simpler data set, which Atul had shown. So this is the data set for body fat prediction data set, right? So this is the data set which we have looked at, right? So you just download this data set, and I've already done that in my existing system. Okay, then we go to Orange. So this is Orange, just working with Atul when we're doing this. So let me just start with a new file. Let me just delete all this and start with file. Okay, you go to file and you select on the file, right, which is this one. Okay, so we selected this file. Now in this you can see, so this data set, I'll just show you what the data looks like. So this is somebody's data collection for body fat prediction. Okay, so here you can see this is the data where what they are trying to do is they are trying to predict the body fat based on some density which they have collected, the age, weight, height, neck circumference, chest circumference, and so on, right? So these are all the data which they have collected. So we have to make a predictive model where we'll be able to predict the body fat based on all these data. So for example, let's use the same data set, but instead of predicting, measuring the density and measuring the neck and chest and all that, let's just use the ones which are commonly used. For example, so here, when I click on this, will be my target. My target is the body fat, and the features that I'm going to use is age, weight, height. So these are all I will use, and the other ones I'll just skip. So here, when you click on this, you can either feature, target, beta, or skip, right? So we'll just skip all this data, right? So all this data will skip, and we click on apply. Okay. So again, if you're not used to this, like Atul said, one trick is you can go to the ChatGPT. So for example, here I've gone to ChatGPT like Atul did, and we just pasted the same, uploaded the same data set into that and said that, wrote a little prompt. So if you remember the first lecture which Anish had taken about prompting, so here the prompt just went away. So here the prompt I wrote is that you are an expert in Orange data set, and please help me, Orange data mining, please help me make a predictive model for body fat using this data. So it is giving me the step-by-step process. So you launch Orange, go to new, the file thing we load and so on, right? So this is what we're doing. Yeah, Atul, you have to take over?
Yeah, if you want to like briefly summarize, then it's okay. But if we have time, then I can join later on also.
No, please go ahead. So I will come back to this later, right? You want to take over from where you left off, or you want to make another model if that is fine for you?
For now,
okay. So I think you can go ahead and take over from where you left off.
Yeah, I think it would be better. I can just at least show how to create your first model. Yes. Then if there is any important question, then I will take that, and you can also jump in at that time. Yes. So I have started sharing my entire screen again. So sorry, there was some urgent call I needed to take. Yeah. So to continue, I used the select column, and in select column I had set some certain settings there, and now comes my first model selection thing, like which ML algorithm I want to use. There are so many. Random forest comes into my mind by default because this is one of the best model that I have always worked upon amongst many. XGBoost is another one. In real world, there are so many other like programming models are also there, which are not in Orange, but in case of Orange, out of given, my favorite one is XGBoost and Random Forest. So for now, let us first take Random Forest. So I can see that this particular setting, data to data, is correct. Can you see this cross over there? it means you cannot click on it and you cannot select. So feature and preprocessor is not logged in for now or disabled. I can only select data and data. I can connect these two only. So I have connected it. Okay, I have connected it. Now, what is the next thing that I can do is, okay. So next thing is there, you can see as we move to the next step, the number of widgets that we can use are quite limited. Amongst these, the most important widget would be my test and score that I will be using. So I have selected test and score, and in test and score, the default setting would be from learner to learner. Basically, today I can't go into detail like what is learner, what is model, what are the different settings, but you can see only one, this learner to learner thing, it can only be connected. There is no other option available. Another note that I need is from select column to test and score, I need to connect. Basically, that what is test and score visit? You can either ask ChatGPT to simplify it, what is test and score visit in Orange. It will like explain it to you. So right now it is going very slow. And my favorite is, in this case, my favorite is not ChatGPT, the official documentation of Orange. The Orange documentation. And in this one, I personally would go through each and every visit category through visit. So here it is test and score. I can go through it. I can understand it. I can like here it is very well detailed explained. Like what is test and score, what are the different scenarios where we can use it. Today I'm demonstrating it to you in a classification machine learning problem. There are other types of machine learning problem also, like regression models. But today I'm showing you in a classification problem. So what I connected first, my data set with the test and score. Another one is my data set to ML model and ML model to test and score. And let me also tell you that there can be different ways of making a model. This is one of the way. Here you can see from data to data, I can connect. From data to test data, I can connect. So right now I'm not testing it, I'm training it. So I will connect data to data. And if you double click on it now, you can see some value. Congratulations, your first model is ready. It has an AUC of 79%, very bad. It has a CA value of 72%, F1 score 71%, precision of 71, recall of 72. MCC is also one of the statistical parameter. I forgot the full form of it. But if you see, it is of 79%. And let me, if I might not be able to read out the entire paper if you go through it, the different scores, what are their values, what are their formula, everything is there. But the final value that we get somewhere around 90%, 85%, those kind of numbers are there to create a good model. You can see here the different settings here, they showed different types of ML algorithm like random forest, logistic regression, SVM, KNN, AdaBoost, all those sort of things are there. They can be done in our settings also, setup also. And everything will have this statistical output. Right now, we made a very like great blunder that sometimes will happen to you also. That's why I intentionally created it wrong. I will show you now. But before that, before closing this screen, on the left-hand side, can you see cross-validation? There is cross-validation by feature. There is random sampling. There are other setups also. Generally, if someone is learning for the first time, and if he is reading a classical text, there we used to study like out of 100 given rows of data, we try to do 70, 20, 10. 70% of the data we train, 20% of the data we use for testing, and 10% of the data for evaluation last. Those sort of things happen. But with evolution of machine learning, my personal favorite became cross-validation. This is the third thing that I'm dropping on you to study yourself, because again, cross-validation will require a lot of time to explain. Cross-validation in machine learning, just go through this particular image and text, this one. You can go through this image, like how different folds are made and how ultimately a model is created. But for now, I'm telling you, at least with my experience, K cross validation, this particular cross validation is one of the best thing, one of the best setting in model creation that we should use, and we will write in our methodology also that we use cross validation. And generally, I tend to use 10 in the number of folds. Maybe some other day we will discuss what does this 10 mean, what does cross validation mean, or you can read it on your own. So now, for now, I'm closing it. So what blunder did I make? Can anyone guess quickly within a minute? If not, then I will just answer it myself because it's already 9:44.
You have not used the pre-processed data, have you?
Yes.
Yeah.
And what is the importance of this pre-processed data? If you see, my data set has is of different range. If let's say here it is 50, 31, then if I use any other data set from any other institute, my model is bound to fail. It will not be able to analyze. You can simplify these things. If you are not able to understand it, you can go to ChatGPT. You can simply ask, what is the significance of, I'm not sure, I will not dictate everything. I will simply show you the things. What is the significance of using normalization in orange for my data? It will tell you many different reasons. One of the most important is like normalization or scaling. Here, the values are like 0 to 200, 15 to 60. BMI is there, insulin level 0 to 800 plus. I didn't see that is even if 800 values are there. Why to normalize? Oh, because SVM, KNN, and PCA that I skipped, though all those sort of things depend on how much value is given. Features with larger value, for example, insulin or glucose level, they can dominate over others. For example, here, if some patient has an insulin level of 800, or if some patient has a glucose level of 200, machine will become biased over other parameters. For example, if BMI ranges from 50 to 15 to 60, 16, and diabetes pedigree function ranges only from 0 to 2.5, machine will think that this is 800 and the top value is 200, that it is more significant than the value of 2.5. That's why we need to convert everything between 0 to 1. So that's where normalization comes into picture. So 0 to 1 is 0 is minimum value in the data set, 1 is the maximum value in the data set. And I will just simply show you. Can you tell me the formula? Anyways, you will not be using this formula. I'm just showing you the formula for normalization. Because in the backend, machine uses this particular formula only. It is minimum to create an scale. Any value minus the minimum value divided by the maximum value minus the minimum value. Those who don't want to go into mathematics can literally skip it and forget it. Those who want to understand what is going behind the scene, this is the thing. Everything is calculated using this formula. So now in my data set, I will simply go to pre-process. I will choose normalize to 0 to 1. I will use this one. And now I will just place it at the top. I will click. And again, I will use my select column. It depends on the type of study, whether you want to use select column, whether you don't want to use it. But generally, I prefer to keep it and then random forest. And I will just quickly confirm whether my select column has the correct values at the correct place. Okay. And lastly, my test and score. And I will connect my random forest to test and score. And if you notice, as soon as I click, as soon as I connect my random forest to test and score, since the machine is capable of handling this many computation, it will quickly analyze. If I don't click on it, I don't see any model value, any model name or value. But if I connect it, it will quickly create a model, because machine learning models are not that computation heavy. Images, that is deep learning, those are computational heavy. So I hope you saw the circle, the quick circle that was drawn. Now my model has been created, and this time it is normalized. It is using normalized data. I will also show you how does this data set look like. So on the select column on the right hand side only, if I want to visualize my data, I will click on my data table. Can you see earlier there were pregnancies like 0, 1, 2, 3, 4. Can you see now the minimum value would be 0. The maximum value for the highest number, it would be 1. Similarly, for all other parameters, everything has been set between 0 to 1. This should be the correct approach. And then my model is set to be of correct value. So whenever I am using it in my testing environment, later on with other data set, it will perform better compared to earlier one. Earlier one is pathetic. It had a blunder. Ideally, it shouldn't be there in any case. So now I will go with 10. Rest all the settings I'm keeping by default. So I saw that my random forest is having 79% of AUC. F1 score is also not that good. So I will try to pick up any other model. Let's say I will use AdaBoost. Now I can drag and drop all the models that I like. Logistic regression was there. What was the other model? XZ, here XZ is not there. SVM is there. So whatever models you studied in this particular paper, it is not readable for me. Here, so random forest I used, logistic regression I used, SVM I used, KNN is there, GB and XGB boost they are not there, ADA boost is there. So SVM did I use? Yeah, SVM used. KNN left out. So I can just click drag and drop. So I have used all the model. I can simply connect it with test and score. Like that only. And everything is handled in the backend. Now, if I double click on it, I can see.
Box also came. What is it?
Better. She knows.
Now I can see that 1, 2, 3, 4, 5 models I have created. Amongst these 5 models, for me, in this case, logistic regression was performing better in terms of AUC. Similarly, I need to study all other parameters and then I will pick up the best model that is done in this study. Now, you might argue that in the research publication, people have shown 90% accuracy. Luckily, in this case here, people had shown 72%, but for other data set, there are accuracy of 90%, 95% are also there. So it depends on how good is your data set also. It depends on what are the different hyperparameters. That is the 5th thing that I'm dropping on you. I will come back to it. Just let me quickly go through the second paper on machine learning model on diabetes prediction only. So in this paper, what the author tried to do was they used the similar kind of approach to create a machine learning model. Ultimately, they created a mobile app. Someday, we might even organize a vibe coding kind of thing where we can show you how to create a mobile app or a web app using Streamlit and all other tools to demonstrate how your model works. So they went ahead one more step further and created a mobile app. But before that, they used the same sort of approach. They used the logistic regression, random forest, all those sort of things. And for them, it appears that XGBoost performed best. And the second best was naive Bayes. And in case of Orange, XGBoost is not there, AdaBoost is there, but naive Bayes is there. I saw it somewhere. So I will just drag and drop it, this one also. And that's how, in my discussion part, I can also compare. Like in case of, in my case, logistic regression performed better. I will just quote my logistic regression performed better as compared to this earlier study. There might be many reasons. For that, you need to study Orange in little bit deep. For example, if I double click on random forest, you can see there are some settings. Right now, I didn't tweak it. Ideally, when I'm working on a real project, these settings I need to change depending on my problem statement. You can take help of ChatGPTs. What are these hyperparameters? You can take a screenshot, put it in the ChatGPT. It will answer you. It will help you for your particular case. But in reality, I will suggest you don't rely on ChatGPT just to solve your problem. Try to gain knowledge, have a better understanding so that every time you just need not to ask everything from ChatGPT. So in random forest, there are some settings. In AdaBoost, if I double click on it, there are some different types of settings. All these things are called hyperparameters. So next thing you can ask ChatGPT, what are hyperparameters? Now this thing you will study yourself, hyperparameters in algorithm, ML algorithm. It will tell you so many things. I won't go into detail. I will just show you one thing that is there. That is temperature. Because of ChatGPT boom, everybody knows, like in case of ChatGPT, if someone creates his own chatbot, there is some setting called as temperature zero. It will a straightforward answer. It won't show you creativity. If we to move towards one, it will go with more creative answer. Similar settings are here. For logistic regression, there are different types of regularization type, L1, L2, and some strength is there. In case of random forest, there is one important hyperparameter, that is an estimator. So the purpose of showing you through this is a very concise way of showing you what are different hyperparameters that are commonly being used. So if in a paper, suppose these two paper only, if you see some of the hyperparameter settings, you will see are mentioned in the documentation. If you don't understand those, simply ask ChatGPT, like what is an estimator in case of random forest and what should I select in my random forest, in my orange workflow to get a better output. So it will try to help you here. Like in case of my setting here, number of trees were 10. If I increase it to 20, automatically a new model would be, the previous model will improve. So you can see now accuracy has increased to 80% just by changing one value. Did you notice it? I don't remember. I don't know because I'm not seeing any one of you. If I just change it back to 10, it will go for 79.7. So that's how values change. So what should be the optimum value for me? It depends on my problem statement. It depends on how previous studies were performed, because they have explained which hyperparameter works best for our problem statement and what is the reason. You can go through that. So that is a common workflow to create a model. If you are with me till now, if there is any doubt, like we can have a 5-minute discussion. If you are not able to understand anything, please shoot it so that I can know why I was not able to explain it to you. And I'm stopping my screen sharing
Yes.
for the timing.
So Atul, now, so we made the model, right? And now, so basically this model is now ready for predictions, right?
Yes.
So that's the thing. Now, can you tell us what is the next step? So how, for example, let's say I am a researcher, I made this model and I want to give it to my field workers, or I want to give it to people in maybe some other group of researchers to use this for prediction in their own patients. So how am I going to, if you could quickly show us how you could save the model and then use it in some web application or some other way for doing the prediction. And once you're done, I think Dr. Shalini has also asked a very interesting question. Why can't I just ask, and if you could have Atul's answer this, why can't we just ask ChatGPT to do all this?
Yeah, we can do it. Later on,
Yes.
ChatGPT will improve to an extent. For example, even if right now, if I ask it, make an OWS file,
Yeah.
it might make.
Yeah. Can you just share your screen if possible? Yeah.
Oh, sorry. Yeah.
Yes.
When I forgot to share the screen, I simply wrote make an OWS file and it is analyzing and it is creating. But at present state of ChatGPT, I have seen that OWS file is corrupted and it is not working to an extent. Then it should be. Another thing is, did you notice, like I mentioned, it forgot to use the pre-process step. So if you are dependent on ChatGPT, will your model be any like research grade level model or a good model? Because ChatGPT is prone to make mistake. It is like not, I won't consider it like it is a foolproof plan. You should have a decent understanding. Similar way,
Yes.
like earlier, as Dr. Om also mentioned, I am doing programming like since my entire life has like when I was in class 6, since then only I'm doing programming. Today, ChatGPT has made my work a lot easier, not just easier, a lot easier, that it can write numerous code for me. But the thing is, if I know how to write in Python, if I know how to write in Java, I can understand that particular code. I can pick up that this particular code is usable for my workflow. If I'm just dependent on ChatGPT, okay, create an entire workflow or create a game for me, I can be successful in a basic program. But if I want to create an enterprise level program, it won't be able to make it. So for example, here it has created a workflow. Let's see if that particular workflow is any significant like value. So I have saved it here. It is here. So can you see the OWS file that it created has some error on line 10, column 31. And when you go into detail, it will throw up some decent level of error. So it is better to drag and drop and make your own model than to troubleshoot this error. I can troubleshoot it for you also. It is it is telling there is some XML parsing error, but then you should have an understanding about XML. If you are a medical researcher, it is better to do research in Orange than compared to learn XML errors. I hope you are getting my point.
Yes. So absolutely. Now, so we have this model now. What do we do next to use it for, like we said, as something meaningful?
Yeah, there are a few things that we can do. First is the easiest one. For example, if I go through my table and if I select logistic regression perform better for me, let's say. So I will select logistic regression.
Yes.
And I will try to export the model. Just click on logistic and here
save the model. Yes.
Save model. We can save the data also, and we can save that model also. If I just double click on it, it will ask me to save and save as. I will click save as because I want to later on I want it to be fine. Otherwise, I will forget where I saved it. For now, I will just save it in this particular folder only. Okay, and save as. What was this? So I will name it logistic regression model only, so that I can remember if I want to compare which model performed better. And I will number it as 1 only. So my model is saved. If I go into my Finder, yeah, here it is. So you can see it has an extension of PKCLS. Generally, when we code in Python, one of the format in which model is exported, it is PKL.pkl. In case of Orange, it is PKCLS. Some little configuration difference is there. I won't go into that detail, but that will help us troubleshooting later on if we understand that these both extensions are different. So now one thing, how can I use it? I can create a new workflow. And now instead of loading that particular file and CSV, first thing what I will do is load model. I have saved that model. I will double click on it. I will click on these 3 dots and I will try to load my model. So this is my model. I will click on open and close it. So my model has been loaded. Now, second thing what I need, I want it to be do some prediction. But the problem is on which data I need to predict. So since I'm working in Orange, for now, I will use the same data set. In your case, if you have a separate CSV file, or if you have used 70% of the data in training, testing, and remaining 30% of the data, if you kept it separately, you can use that. For now, I will use the same file that I used while training. So I will make sure that this is target. So while using the prediction model, the saved model that we created just now, one thing to keep in mind, we need to have the same setup that we created during our model making. Remember, we used pre-processing. If you don't do pre-processing and if you directly click on this connection, the model will not be able to work correctly. Although it is showing you like logistic regression is telling 1 and outcome as 1. The logistic regression model is telling that this is not diabetic and outcome is showing you as not diabetic. It is matching. But in reality, it is a mistake. So this is the thing that you need to keep in mind. Again, the data, how you trained, again, in case of prediction, you should use the same setting. So for example, I needed to use pre-process, and in pre-process, I need to select my normalize feature and normalize to interval 1. This was the only setting that I used. If I had used any PCA or any other setup, I will also mention that here also. Now, if I click on pre-process and connect with my prediction model, this time my model should perform better. And it should be at least a model, whether my model will perform better or not, it depends on how I created my model. I created it with some 80% accuracy. So yeah, when I created my model, there was also like 20%, it was bound to fill, but now model has correct setting. So I restored the original setting. And now I know that the first row, if these are my values, now these values have been normalized. And the logistic regression model said that this particular patient, the patient number 1 or the column, this first row, this patient is likely to have diabetes. Second one does not have diabetes, third one has. So this is how we predict. This is one method. Then, like Dr. Om mentioned, if I want some technician to work in field, then what are my options? The method that I can think of is creating a Streamlit tab. Dr. Om knows how to create a Streamlit tab, but if most of you don't know, it requires a little bit Python programming. But again, you can ask ChatGPT. I have my model. Now I want to use it with Streamlit web app.
So
Write
there
the
is
code. Yeah.
there is an easier way also. So Streamlit app may be a little difficult because people will have to
Yeah.
install the Python and all that. So let me just show you one way of doing it, if you could allow. This also answers some of the questions which Dr. Shalini had also asked. So one way of doing it is, there is a system called. I'll show you the entire thing once it's finished. But just to show you how you can actually use this, here is the data set. We did all the analysis and everything, and we made the model. Now, one way of doing it is you could use another system which is similar to ChatGPT, which is called Claude, which actually can make web applications within the browser itself. So you'll not require any other additional software to think. So we took the ChatGPT model and everything, and we put it in Claude. And I just wrote this prompt: make a web application that I can use. Below is the Streamlit application. So what I was showing you was a Streamlit application, which actually will require you to install some software, install Python, and install the Streamlit library using pip and all that. It will be a little complicated. So here we just said that this is the Streamlit application, make it into a web application, right? So what this has done is it has actually converted this into a web application. So I used another data which I was trying, which is basically body fat predictor. So here it did this. Now I enter the data, just click on body fat prediction, and it does the prediction, right? So you could actually, so now I can actually copy or maybe publish this and share it with you, and you could try it out yourself, right? So there's another way of doing it. Of course, if you're used to using Streamlit and Python, which will probably require another course, Atul, all and so on. But if you're used to that, is better, because Atul knows this. We have actually made my own entire EMR system on Streamlit, right? So it's beautiful. The good part about, again, a lot of coder geeks like us, is that if you're using it in Streamlit, you can actually change the code in Python straight away, and then it shows up on Streamlit, which is very good. If you're using something like this, then probably if there's something wrong with the code, then you are in trouble. But if you're already well versed with Python, and most AI systems are also well versed with Python, then troubleshooting becomes much easier with Streamlit. And especially if you're not using something which is mainly for research and it's not for production grade. For example, you're not using a model which general people are going to use, only researchers are going to use. They are used to Streamlit. So that is what I'll say. Atul, yes.
Yeah, thank you. You gave me some time to take some breaths. This was the second thing that I was about to come. Thank you. You took it like you explained it very well. So basically, when I was mentioning Streamlit, I was about to mention that it requires a basic understanding of Python. So you mentioned, someone asked in the comment, like, when ChatGPT can do the entire thing, then what's the need of understanding all those sort of things? Again, ChatGPT can generate a very beautiful Streamlit code, but with different version, that some settings might change. Like if ChatGPT is trained on version earlier library, then with the latest version of Streamlit, it might get some error. Then you need to understand where the code went wrong, what is the different version of the library. Similarly, Cloud Code and all other settings can help. Nowadays, web apps become easier with some these coding CLIs. Whether you use Cloud CLI, you can use Gemini, there are so many CLIs are there. There is one more tool that is there. You can Google it. It is called Lovable. And it is also used to create web apps. You can just prompt it. I created a model in Orange and simply write, I want to create a mobile application or I want to create a web application. It will show you a beautiful UI, and it will give you a space or placeholder where you can just place your model. It will do the entire coding. But the thing is, if there is a single mistake in the code, and if you don't understand, then troubleshooting becomes a little bit difficult. So a basic understanding of coding is always good to learn. There is no harm learning in basic coding. I think it requires hardly 10 to 12 hours. If someone practice 1 hour daily, within 12, 15 days, he can understand it. But coming back to our topic. Sorry, you were saying something.
Please go ahead. Yes, no.
So basically, I just quickly wanted to finish it off that there are many ways through which you can use these model. In case of research work in publication, till this step, it is sufficient. But if you want it to go with forward testing and prospective testing, whatever you call it, then you can create a web app, you can create a mobile app. Like it is mentioned in this particular paper also, you can go through it where it created a mobile app like this. You can take a screenshot of it, give it to ChatGPT, give it to Claude. They can understand how does my app look like, and it will create it for you. At least the basic version, you can make it. Another way that I think Dr. Om can resonate is what in today's scenario, what I like is most, not just the web apps. You can also connect your model with your N8N automation tool. It can connect with your WhatsApp setting, WhatsApp API. It can connect with your Telegram, whatever WhatsApp everybody is using. So on WhatsApp, how you can do, if someone has a basic understanding, it is not for all, and just a little bit disclaimer. If someone has a basic understanding of automation, I will just take 1 minute. You can use WhatsApp API, connect it with a chatbot like LLM, let's say Google Gemini, because it has some free tokens, okay? And it will be fast. And then the third one, there is on the agent tool, you can connect your newly created model. In the tool setting, you can connect it there. So if someone is setting, okay, doctor, my glucose values are this, my BMI is this, from the text value, your LLM model will pick up the numbers and it will create a data set in desired format. It will call the tool. What would be the tool? It would be your model. It will predict and it will answer back to your WhatsApp API. And you don't need to create a separate app, because patient might be like, okay, for diabetes, I need to have this app. For PCOS, I need to have separate app. For third disease, I need to have another app. So everything can be done using WhatsApp API also. That's what I feel. But that requires another course. Knowledge of, it is like
we'll have a separate course on we'll have a course on automation.
How big is automation? So that is one of the things. So that's why I'm not demonstrating it, because it requires, it would be a very long demonstration. So quickly, so that's how we created diabetes prediction. Is it limited to diabetes prediction only? No. Similarly, I shared a folder with you. I hope, Dr. Om, did you share that link?
Yes. So I think, we have shared the links. We'll also put it on technology.com. So we'll put all the data there as well. So we should do it by Sunday. And I'm sure a little advanced level thing. So if you could probably go back and revise this entire video also, maybe look at it a couple of times, you'll get the gross idea of what we are trying to do here. And that's it. That's the thing. Yes.
Yeah. So since it's already 10:15, I think in 2 hours time, we hardly have 15 minutes, but still I would like to a few things in the second model, because I intentionally kept that one a little bit harder, because in real world setup, we don't get such a nice clean data. So I have deleted everything in my setup. I'm starting a very fresh. This time I'm again selecting file, and now instead of diabetes, I'm going with my second model. I'm not showing you that PCOS paper. You can go through it in your free time. I just selected the PCOS infertility CSV file that was mentioned in the methodology of the particular study. That study was done in Python, but thanks to Orange, we can do it using no-code tool. So now I will first show you how does this data look like. So right now I didn't change the settings. I can either open in Excel or I can just see in this data table. Can you see there are some AMH values? Right now, what machine is thinking, this AMH value, the color is different. So right now, maybe it is thinking that this should be the target variable, but it is not. The second thing is serial number. Third thing is patient file number. Fourth is PCOS YN. So whether the patient has PCOS or not. The second last column is beta HCG on first settings. If I'm correct, it was labeled as 1 and another one was labeled as 2. Though endocrinologists, you people know better, like why there are two values. I didn't look it into these things, but yeah, there were two values of beta HCG, 1 and 2. So now in real world, this type of data set is what we create. The problem is in real model, when we make a real world model, serial number is of no significance. If we supply it, we are making a falsely wrong model, because then it will assume serial number 1 if it doesn't have PCOS and last one has PCOS. Let's say, yeah, here it is 541 has PCOS. So machine will think that the higher the value of serial number, higher is the probability of having PCOS. The same thing might happen with patient file number. Initially, this 10,001 or whatever number is there, it doesn't have PCOS. And if I go like the last number is this 10,541, it has PCOS. Machine might think it in this way. Machine might think in any different way also that we are not able to see right now. But that's why we need to skip these two particular columns because those are not significant for us. Can we skip these two from starting? I would not recommend you to do so because as I told you earlier in our previous project, that if for some reason, if we need to trace our patient, we need some identifier. So that's why initially we take as much columns, as many data as possible. Later on, we try to clean it up. So this was one thing. Second thing, if you go into the header, can you see this? There is SL dot, then a space is there, then NO is there. Patient space file space NO, then dot is there. So there is space, there are special characters like dot, there is a special character like bracket and slash. In case of programming, these special character and these white spaces, sometimes they create problem with the code in the backend. Right now you are not coding, but a code is running behind the scene. So it might create problem. We need to rename our headers. First thing, we need to drop the columns. We need to rename our headers. So these are the two things that so far we have seen. The third thing is, I'm not able to find it, but in this particular data set, there is a missing value. Although here it is saying no missing data, but I had read in the particular on Kaggle, I had read that this particular data has one missing value. Whether it was cleaned or not later on in the revision, I don't know, but I read this, so that's why I'm mentioning it. So if some values are not there, then we need to drop out those rows also. Now, can you see in this beta HCG, there are different values, 1.9, and I can see 1134.4. So there is a huge range from 1 to 1100. There is even 21,084. So there is a huge range. So again, what should we do? We need to normalize it. So all these things we need to do. So normalization, I have already shown you. But how do I change? First thing, how do I drop certain value? So I will double click on file. For me, this serial number is of no significance. So I will skip it. Patient file is of no significance. I will skip it. PCOS YN. It is not a feature. It is a target for me. Beta HCG is a feature, numeric value. Beta HCG second is a numeric value. Okay. Another thing, can you see AMH? It is taking value as text. So this is a common mistake that we do. Like in Excel, here 1 is written. It is numeric. But if someone writes 1 in inverted comma or in some other way, it is converted into something called as string or text format. So that text format value is not usable in machine learning model creation. Anyhow, we will have to convert it into numeric value. So what had happened when whoever created this data, they wrote it, they created the file such that the image value came out to be text value in the text format, not in numeric format. Although when I am visualizing it, the image value I am seeing as a text only, but for machine it is a I am visualizing it as a numeric only, but for machine it is not numeric, it is text. So for machine it will create problem when we try to make a model. So now I need to correct these things. So I have corrected one thing, that I have skipped these two columns. Now the next thing is I need to clean my data. So I will select a new widget that is called as edit domain. In case of edit domain, I can select, like, my first widget is here selected, this beta SCG value 1. Now I can select a new name for it. For example, beta. So what has happened now? Sorry. By mistake, I clicked on some checkbox that I shouldn't have. So now what has happened? There was space, there was a bracket, there was a slash. I don't want my model to fail just because of these kind of textual error. So I renamed it to beta SCG1, and underscore is a well accepted special character in case of programming. So that's why I used underscore in case of putting a space bar. Second one, I can put beta SCG2, sorry. And I can click on apply. The third is AMH. I will rename it to AMH, and instead of text, I will select numeric. So now can you see the end is denoted for numeric value, and you can see AMH in the bracket and nanogram per ml. It is converted into AMH, reinterpreted as numeric. So I will have to select these settings. And now once I have selected this, if I visualize my data now, these values will be now in a numeric format. Yes, I remembered correctly. There was some missing value. So you can see that 0.2% of missing data is there. So there was some data that was missing. And since it was like taking it as a meta, now I also need to take this into consideration, because meta is not analyzed in my study. So when I click on select columns, I will have to be specific. Instead of select data, I will have to click data to data. Here, this AMH is mistakenly treated as meta. I need to drag and drop it and features. And now if I visualize it, you can see I connected it like this. I could have connected edit domain with this selected column also. With practice, you will understand like how these things are connected and what should be the way. There are multiple ways to connect it, multiple correct ways and multiple incorrect ways. So now if I click on selected columns, okay, sorry, this one I have shown you. Now if I click on create a widget of data table, you can see AMH value. Can you see the color has changed? This color has changed. So now I can correlate. Now I can understand that this particular value is in numeric format. Earlier it was in text format. That's why it was having a color of this brownish kind of thing. Now, if I need to pre-process quickly, that first thing I need to do is normalize it. The second thing, so normalize, because in previous study, we used this tool, it was there. I also need to impute the missing value. And imputation, I can either do this before normalization, I can do this after normalization. I can simply drag and drop which one I want to do first. With practice, you will understand what should be the optimal settings. Personally, I find if I want to remove something from my dataset, I will remove it first, as compared to later on, like if I need to remove 1,000 rows. So why to normalize it if in the end I am going to remove it? So that's why I prefer removing it in the beginning only. So now there are two pre-process settings I have set. Impute missing value. First one, remove the entire row of the missing value. Then normalize to the interval. So now I will again show the data. since I don't remember which value was missing, I can't just jump to that particular value. Okay, so yeah, again, you can see what went wrong here. Can you see when I double clicked it, there was only one value. So you can see somewhere I made mistake. This was here, selected data to data. So that's what I was telling, that sometimes we forget to click the correct setting. So now if I click here, everything is normalized. And those who know maths, they can understand that this was a very long value in points. That's why it is showing it like this. You can convert it into numeric format or readable format. It is a little bit in mathematical format. We can show it like this only. But anyways, all the things are tackled by machine, not by us. So we don't need to worry about how do we read it or how do we convert it. We don't need to do it. Machine will tackle it itself. So the next few steps, it will be same. So I don't think I need to demonstrate it, Dr. Om. What do you say? Do I need to create the entire setup or let the user?
Let them try it out themselves.
So you can do it in the similar way, whatever problem statement you face or whatever research topic you figure out. These are some of the most common widgets. You can see I have not demonstrated paint data, I have not demonstrated data info. Rank feature, I would like to demonstrate that earlier setup is there. Which this is my data table for diabetes 1. So if I select rank, then what features are the most prominent one? As per, there are some scoring methods. All of us might know chi-square. So this is one type of calculation, statistical calculation, if something is important or not. In case of diabetes prediction, it does not hold any significance. That's why it is showing as NA and it was not selected. Here, something called as gain ratio and information gain. It is of importance. So that's why it is selecting that these 5 are important. However, in this particular study, the data set was not up to the marks. That's why information gain is values are showing 0. But if you have a good data set, you can try it out tonight or within a few days, you will see certain values here. In my pathology models, I do have values here and which I showed in research work also. So that's how we connect. Again, there are so many widgets. I cannot show each and every widget today. So that's a practical demonstration from my side. I'm ending it here with one more thought that there I shared one more paper. So it is not just the disease prediction that we can do. We can also do a side effect prediction. So this was one of the fascinating paper that I found, which is related to endocrinology. That's why I'm showing it here. So it was predicting pancreatitis risk with antithyroid drugs. Honestly, I don't even know whether antithyroid drugs cause pancreatitis risk. I'm assuming because this paper is there, so it should be there with some drugs. And they did a great study, and in their methodology, they used very large data set. And since it is a closed data set, I didn't have access and I couldn't find a similar data set anywhere on the net. That's why I cannot demonstrate it. But in the end, again, in a similar way, you can create your model. Here in this, all we can do is from published work, we can understand what different variables they used using programming language. For example, here they used post-treatment, they used lifetime after E05. It was this ICD coding, if I'm not mistaken. It was mentioned there. Drug to AP, then gender is, all those sort of things are there, PTU, PP. So all those variables are there. These variables will always change with your problem statement. So you should better understand your problem statement, then only you can define your variables. I'm a pathologist. I'm good with deciding what variables should be there in my study when I'm doing any pathology related work. But if I need to do an ML related project for an endocrinology or for any other stream, I will go to subject expert and I will try to understand each and every variable that I should include. I won't use like my mind in that case because I might not think to that level. I might be good in machine learning model creation, but I'm not good in understanding the problem statement. So understanding the problem statement is the key to your success. If you don't understand your problem statement, there is no way that you can create a good model. I have a mail. I don't want to reveal that name because I forgot to create a black line on that name. Someone approached me as a freelancer and he wanted to create a mammogram prediction model for breast cancer. And the data set he shared with me was of histopathology images. And I was like, brother, do you know that radiology and pathology are two separate branches? You can't just create a prediction model using histopathology images for a mammogram. So these kind of things happen when we work with our engineering counterpart because they don't know these sort of things and they're not supposed to know. That's why teamwork is there. So that's all from my side. If someone has a doubt, you can shoot it up. I hope I was able to make some sense.
Yes, Atul, thank you so much. 2 hours of talking, which itself a feat in itself. Thank you. So to all the endocrinologists and other physicians and other people who are listening to this, it may sound a little tough, but there are a lot of things I learned myself today. And thank you, Atul. Thank you so much for predicting. So this is, like Atul said, it's brief 2 hour summarization of a 90-hour session, just to give you a glimpse of the possibility of what you can do with the use of AI in these things and use of Orange. So again, if you're really interested, we could actually have a 90-hour session on Orange if possible in future. But as of now, this gives you a glimpse of what you can actually use it and the predicting. So probably go back and view this video again and see the step-by-step process. And I think one thing which Atul did very beautifully is to show you the common ways in which you can make mistakes. For example, that data to data or selected files to data. It's a common error, which rookie error, which a lot of people make. So these are things could. So what I'll suggest is when you go home, when you have time, just download Orange and start using it in some of the free data sets that are available on Kaggle, and then see how it works. You will make mistakes, you will find it frustrating, but that is how we learn, right? We learn from our mistakes. And recently I saw this very beautiful video which says that the more your brain struggles in these matters, the more it grows, right? So that's how it ultimately is. So thank you, Atul, for this. We hand it over back to USV. We are going to have yes, please, Atul.
Sorry, I forgot to mention two things. There are so many things in my mind, and I'm restricting. I can give that many knowledge only in 2 hours. Otherwise, it would be overwhelming. But two things. First is like you mentioned, someone asked if ChatGPT can do these things, then why to do? First thing, don't forget if you are so dependent on LLM, your mind will stop thinking or will stop creating visions on how to approach different problems. Any LLM, not just today, even after 50 years, it cannot do new things on how much data we have trained. For example, till today, Python is one of the best language. It will be able to create Python code. Rust created after that. So if model has a cutoff date of some, let's say 3 years back, then it won't be able to make a program in Rust. If in future a new language comes up, model won't able to understand it. Model will create some stupid things. So that doesn't make sense. So human mind, we should use our mind. We should, even today, I do programming a lot. I use LLM also, but still for a glimpse, I put any research into ChatGPT and I will ask it to summarize. But it is not the case that every time I'm just dependent on summarizing it on ChatGPT. For today's talk also, all the 4 papers that I have shown it to you, in my iPad, I have created my own notes, not dependent on ChatGPT. What are the key values that they have signified? That's why, like I was showing you, the different variables these particular studies are using. So that's how I understand. I don't rely on it because otherwise, sooner or later, it would be your habit. We don't remember who was the third prime minister of India because we are technically used to using Google for it. Yeah, ask our ancestors. They used to remember the phone numbers of some other person who didn't even call them in years. So that's how our mind works. If we don't use our neurons, they will just go jam and you will be like, I don't like what should I call it? It is not a good situation. So I would suggest use your mind, try to vision it. How would you have done it? Second thing, still you will face some error because you are a newbie. And I agree to that. But like you are in a golden time that ChatGPT and other LLMs are there. Just drag and drop any particular study over there. Try to ask it, simplify the methodology to me. And then simplify it in a way that I can use it in Orange. Then do it by your hand, not like asking Orange to create a entire workflow. So that's what 2 things I wanted to convey. Sorry.
Yes, thank you, Atul. Yes, so keep using your brains, and brain is for creativity. So my philosophy in this, Atul, is that you use your brain for the creative and the brilliant ideas, But for the things which require a lot of manual labor, probably that's where AI is used. For example, if you've written a great paper, but you want the citations to be formatted in a particular manner, use AI. But for your original work, probably you should be using your brain. So that's the bottom line. We'll be discussing those things also next week. So next week we are going to have Avnish back, who is going to talk to us about how to write a research paper using AI. And then you'll have me giving a little bit of gyan and philosophy of how AI really shapes up and how we can actually collaborate with people with brilliant minds like Atul. And last week we had Shahir and Avnish. These are the best people who use AI and are practicing doctors. So that's why we have chosen them selectively for this. So thank you, Atul. Thanks once again for the beautiful talk. And back to Anisha.
Yeah.
The closing comments, please.
Yes, thank you so much, Dr. Lakhani and Dr. Atul Tiwari, for that very insightful and informative session. And I'm sure everyone here is leaving with great knowledge, which they can directly start applying. And thank you to all the participants for your active engagement. We look forward to the next session. Thank you so much. Have a great evening.
Absolutely. Thank you and good night, everyone. Bye.
Thank
Thank you,
you.
Atul.
Good night.
Thank you once again.
Yeah,
Bye.
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 Bye.